what I'm here to talk about is a 3D printer. And the 3D printer makes similar parts to what I'm holding up here, minus the wood parts. But I'll pass them around, some of them. The first one is a skull. I just did that to see the quality of making.
You need to know your printout.
I made 30 of them. There should be there.
Mine, I'll share. Okay, here, have this for the one I can share.
Here, you can pass them too. And what these parts are made with is a $119 machine that you have to assemble. So if you look at them, just pass them on back. They're made from fiber that I buy in a 2.5 pound, what they call 1 kilo purchase. Varies from $14 to, I've seen $30 and $40 ones. I went on Amazon yesterday, and here you can see that they have the exact unit that I have, which is this ANET A8 for $119. Now, it's a kit. It took me a day to put it together. The sheet that was the handout has all this information and the websites where to go to. Then the 3D material, I usually purchase it at Amazon too because you get free shipping. And they have all different styles, all different colors. They have even colors that are I'm trying to find it. What it is?
Is that one neon?
They have neons, and they have ones that are what's called rainbow.
Right there.
My unit has, this one only has a single head. There's only one piece of fiber running into the machine at a time. Some people take it, cut it, keep it running, and then put another one in behind it. They also make a machine that has 3 heads or 4 heads, and the computer will then tell it where to switch it to a different color. And that works out good on some items. But what I'm making is parts that I use to make things, and they're quite strong, and I'll pass this one around. I only have one of those, so, and that. Make a structure like that. This is the drone that I have and I fly. The frame is made out of it. It has a camera on it. It flies for about 7 minutes. It will go about a mile away. I told Dave Roush I'd fly over his house and drop a bomb on it. But Dave and I both like flying, and so I've also built stuff for Dave for the airplane. Time clock to keep for the turns. I also have some cookie cutters up here that someone can take home with them. Please ask me before you take them. I also have some hummingbirds up here that people can take home. I'll pass them around, and if you want one, take one. I think there's about 20 of them in there, so there's enough. But I got 2 cookie cutters, I got a Christmas tree, and I got a Superman one. And that. The machine took me 1 day to assemble. It took me another day to learn to program it, and that. There is free software out on the market. This is called Tinkercad. It's made by AutoCAD. You have to do it on the internet, and you can use it for free. And it is a very simple CAD software.
What does CAD mean?
Don't ask me.
Computer aided design.
Yes. And with that, you can make this kind of thing or anything. There's also this one, which is interesting. It's called a turbine fan, and it is done without any support. It is done on my machine. All these parts I've made on my equipment. And I've had it for about a year. I've broken several fans. There's 2 cooling fans, one in the front, one in the side. And the trouble with it was my screwdriver got in the way. Yeah, oops, I broke the fan. And so I designed a little fan to replace it. Or fan blade to replace it, which works, but it's usually out of balance. But anyway, this AutoCAD software uses these cubes. And what this guy is building is this wrench in 3 different parts. And this is on YouTube. You can log into YouTube, go to Tinkercad, and he'll show you. He goes over to these things right here on the side, and picks up a cube, pulls it in like he just did. He'll shrink it down, make a part out of it. He can either make it as a whole or a solid. Just by clicking on those things, it'll make that object, change it, and whatnot. And it is free to use. I was going to demo it here, but I have to use my telephone at home to get a 4 or 5 digit number from them each time I get on the service. And I couldn't get it switched over to my cell phone. So I'm doing it with a video.
Call Wanda. Say, Wanda, stand by the phone. Wait for this number.
Yeah. So if you're going to ever log into this place, and it's fun. They like to do this with kids, young kids. Matter of fact, they even offer classes that teachers can use this to teach their kids how to assemble these things. And you can make basically every part. This thing here was made with Tinkercad. And this piece here is called a needle cutter, and it is done with Tinkercad also. These parts here, there's a website. It's called Thingiverse. You can download literally hundreds and hundreds and thousands of files that are already pre-made in what they call STL files, which is what this equipment requires. And you can download them, use them for free to make the items. That's where this came from. And the other Christmas tree and the hummingbirds came from there.
Dave,
Yes, Mary Frances?
how much education in mathematics am I going to need to try to do this?
Very little. Practically none. You need to be able to, I'm trying to make the chair glides for the chairs in here. And I'm using a set of calipers, so I measure it there and I get so many millimeters there, and I tell it up here on the CAD software so many millimeters, and it's supposed to be the same size. Ma'am?
Does it charge you a fee every time they give you a number?
No. No. It's not a fee at all. It's not a fee to use it. It's totally free. It's made by AutoCAD, which sells for, if you buy their full-blown CAD software, it's $10,000 or so dollars for corporations. Yes.
Can they use something like LiDAR to scan items and then reproduce them?
It's a 3D, I'm not familiar with LiDAR, but it's 3D camera type thing, yes. This lady here was talking to me about doing figures or something, you know. Let's say you want to do this model. You set it down in front of equipment that's available on the market, but this all costs money. And it literally is on a turntable and rotates around 360 degrees, and it scans it with a laser, and it makes a 3D print of that object. This would be hard to make a 3D figure, you know, like a bottle or something like that. It'd be pretty hard to do. It'd be easier to do with CAD software. I use Corel CAD. You can get a copy of that on Amazon for learning for like $60. And it works. But this is free and it's open. They even suggest that kids try this out. And my grandson, who's 15, is going to try it out. I showed it to him and he said, oh, okay, I could see some applications in it. My wife thought I was crazy. I was getting surgery done. I decided I would build this while I'm recovering. I did it on the kitchen table. My wife made me lay a cloth on it. And like I said, the first print was even made on the kitchen table. And it's a fairly quiet machine. It's going through a process. It's making this disc. It's printing on glass. So if you turn some of the figures, you can tell where the bottom is because it is very smooth, very glossy. And that's printed on glass. It's set at 65C with the head on the unit, and the head being, if you want to talk to me afterwards, please come up. It has a copper nozzle. It's 4.4 millimeters in diameter, and it has a aluminum block and a little heater. And this heater takes it up to 410 degrees. And I'll pass that around. It's got a thermostat on it also. That's the white wire that you see with that. And I would like to retrieve my stuff back too, please.
I want to look at that fan.
And I gave the fan out already.
Yeah, it went down that side over there, I think.
Yeah. And then there's other software, which is what they call slicing software. And it's made by Pura. And what you see is happening here in this picture. It is showing the slices that it takes. The slices is the revolution. It's putting down a 4 millimeter bead down each time it rotates around. And it does it one at a time. It squashes down the top of it just a little bit. And so it makes contacts, melts the two pieces together, and lays the next one down over top of it.
Is this a light that's right here?
No,
It's
that's a
not an LED.
thermostat.
That's a thermostat.
Yeah.
And this heats the metal part.
Yeah, the aluminum part heats it, and it goes into a computer that's on this side. This unit is all self-contained. It's got a power supply on this side, and then it has a computer over here, and then it has stepper motors. And that one piece I set around, it's got the thing with the silver ends on it. That's what they call a stepper motor. And there's on this one, there's 1, 2, 3, 4 stepper motors on it. One for the fiber, yes.
That's taking the filament coming out of the top,
Taking the
welding
film,
it together and making what's flat on there. Right. I see where
Right.
it came up a little bit now. Okay. I
and
thought it was something like burnt something, right? Yeah. Okay.
when it makes a solid part similar to that skull that I gave you, and some of the parts that are thick, it does what they call an infill. It does an 8 millimeter, or 8, not millimeter. I forget the thickness of the wall I have it set for. You can set the wall to a certain thickness and the base of it. And it makes all that solid. And then inside it makes, you can either do crosses, you could do all different kinds of things.
Honeycomb.
Pardon?
Honeycombs.
Honeycombs, anything.
It is
And they
support.
call it an infill. And all it does is take up the space and makes it still strong. So it's supported from inside. And it really, you can try bending some of the parts, you're going to find it pretty tough to do.
How long did it take to make the big skull,
Big skull,
the big one?
that probably took about 2 hours. It's not real fast. It depends on the speed and the quality you want. I've seen guys, you can look at my drones and they're pretty smooth, you know. I like making them look smooth. I've seen some that there's a little shot of 4mm piece of fiber shooting off the side, and you got to trim it with a pair of trimmers like this. Go along and they'll trim them off. Well, I don't want to do that. I don't mind the time. I'm retired. I can set it up. And I've seen people with 5 or 6 of these machines doing different parts and that. And a lot of people say, why don't you do injection molding? Well, if you know anything about injection molding, you got to make a male and a female part of that skull, and it's going to be made out of metal, and the person making it is making several $100s an hour, plus the machine he's on is a couple $1,000s. And so you got a lot of money tied up, and then you got to have the injection molding machine, which is a couple more thousands of dollars.
I went on the internet when I heard about this. They were talking about creating the wax for creating a mold, for injection molding with one of these machines too, which kind of surprised me. They were talking about it.
Yes, because you can melt the wax with very strong wax. It's not like a candle. It's a little bit harder, more harder than that. I also make a fiber that I'm holding in my hand, which actually is holding this little motor into this drone. You see it on the end of the thing, but it's rubber, and it was made on this machine. And so you could make gaskets for a car, whatever you want with this. And that's the neat thing about it. This is mainly designed for a nut like me that likes to build things and try different things.
I'm sorry, how do you make rubber?
It is, you buy the filament that is rubber based,
I see.
and you can squeeze that, and you can see it's fully flexible. And it holds itself. But it's very neat. And did I pass one of these around so you guys can see them? No?
How much is the kit cost for the drone?
Oh,
You had to have the motors and,
you gotta have the motors in that. That's very, yes.
What is this here?
The white wire that you see is a thermostat.
Thermostat.
And the silver one, the big silver one, there's two pieces. This is the heater.
Okay.
That gets up to 600 and some degrees. And that is the thermostat that tells the computer to turn this on and off,
Oh my God.
to keep it at the temperature.
So-
Temperature is very important.
Is the heater in the tip then?
Yes. The heater is down in the tip. Let me see if I can get the box open here.
so the serrations on that is the overlay of every time that goes down, there's another piece on top.
Yeah. Okay. I'll pass one of these around on either side. And you'll see there is a threaded rod. That's where the fiber goes down into and is melted down in this moon block that you see here. And there's a copper tip down at the base, and that's what makes the fiber.
It comes out of
It's,
it.
it's the fiber, this fiber is 7.75 millimeter size.
And it comes out here and goes on to the,
or 1.75.
like writing, about like writing.
Yeah. Yeah, it comes out, and looks like almost a hair. And that. And these things, the whole thing runs, this part, the way it is built, runs about $11. And that. And as you see, I have a bunch of them. Well,
What's that for? Did you glue them up?
no. No. I learned I wasn't burning them up. I was changing fiber the wrong way.
Oh.
And found out that I just took these little snippers, snip it off near, well, I'd have to show you, and feed the other one down in, and there's a stepper motor that's, the computer tells it to push more fiber in to lay down a track, and then when it gets to the end, it says pull up on it, and it actually pulls it up. So it's doing all the thinking for you. And all this is made in the STL file, which is done with the stepper, Cura, and that's a free software also. You get it off the internet, and it will then tell you how long it's going to take at the speed that you're doing it. I'm running at about half speed right now, just so you can come up and you can take a look at it. Before it would be going like this across it, and you couldn't see it, so I slowed it up. And I made it bigger than the one blade that I passed around there that's correct. And that, and it also, these are ones that I got off that thing Universe, and it is a cable thing for the cables. You can see these cables here. It's to hold them. It would then be fastened on from here to here, and as this would move back and forth, it is adjusting itself all the time. And you would strap the cables into it, and there's little places where you can take a tie strap, a nylon tie strap, and stick in there and lock them in place.
They
You
made
made that?
one piece,
No, that is all done in many, many pieces.
and then you have to snap them together.
I have to snap them together. And so you can see that it's got to be a fairly accurate machine to be able to do that. Yes.
Have you looked in, I know they can do it with metal, they're making rockets from probably the motors. Have you done any reading about metal parts and that?
They do have a loom part that you can buy. This fiber, it's got the plastic and the real powder loom like in it, and it melts it as it goes through there. And they have wood also, and sands like wood. And they also are coming out with some that look like metal. I mean, bronze and whatnot. You can buy the fiber. That's about $39 for one of these spools. And actually, this will make a lot of material, a lot of these parts.
So you want with this much, I would figure in the amount of that you use.
Probably from here to John.
That's how much of the.
Well,
One piece.
One piece.
One little piece.
One little
Okay,
piece.
okay.
Right here, from here to John.
Okay.
From me to John. And I hate to tell you how many, that trip I could make with this. And that. Yes.
But the whole idea is to save money because of expensive material, because you don't machine out lots of material and making a complex design. That was my understanding of why.
Yeah. This is a machine that I'm making. I call it CNC. Whoops, I lost it.
Is your machine in it?
So you can just about do anything with it when you get a big enough machine.
That's right. This, which I'm not ending up with it.
Oh, it's an ad.
This is the build. It's not getting the one that I want. This is the building of it. You go on YouTube and get it. This is the one I want right here.
Do they do this plastic plus metal, or you have to buy different machines for metal?
That CNC machine, you can put, this is the head that travels across it and has a piece of pipe. Mine's going to be the pipe that this thing will travel on. It's going to be 32 inches. The work area will be 28 inches by 35 inches. And it'll travel over a piece of pipe like this, and there's a stepper motor that will pull this across back and forth. And you can put either a laser head on here, you could put a router on here. A router would give you the capability. The board that this is fastened to is made by Rich Allen. He has a CNC router unit that he purchased. Well, I'm making mine from scratch. And mine, I've seen it actually in action. They call it a lowrider, and the thing will take up any size. If you have a big enough room, you can make it fill this room. And they'll take plasma cutters, and we'll mount a plasma cutter on a head similar to this, and it'll run clear across it, and they'll do a whole piece of metal in a factory and cut it with a plasma cutter or a laser. And they're making them all different sizes. A lot of the guys are making them 4x8 because they can put that in their basement. I don't have the room. My wife would shoot me, so I'm making mine smaller. It's fitting on top of a radial arm saw that I had a Craftsman that the motor burned out in it. I'm tearing it off and putting a table on it that all this stuff will mount to. And these wheels, you look at them, and what it does, it actually rides down along the edge of the table like this.
Where'd the wheels come from, Dave?
Amazon.
You didn't make the wheels?
I didn't make the wheels.
Skateboard.
Skateboard, yeah, skateboard wheels. And there's two of these things, one on one side, one on the other side, and then there's several parts that go up on top of this. There's pipes here that run for this thing up and down, making it go up and down. And for some reason, I can't get that video to show.
I'll show you the rewind arrow on the bottom left corner of the
Circle,
What's this?
It's a rewind, your rewind on the bottom left.
right there.
Okay, well, thank you. And this is what my machine will basically look like. And you can see it's running across.
And that will do the same as what this one does.
Right. And you can see all the parts that I've made. Let's see if I get my laser to work.
Now, is it cutting that metal now?
Okay, this part right here, those are the wheels. And the metal going up and down, there's the thing that travels back and forth. This is a vacuum hose. He's using a router. This looks just like Rich's. He's got that same router on his. I have the controller for it and the computer. That's all in this bag. And I've made a box for it and a cover for it. Someone's got half of it. You can pass that around if you want.
That is so nice.
And that I enjoy making things. And if you like trying different things, this is a cheap way of doing it. And actually with this 3D printer, you could change the head to a laser. If you're just going to, it's a 220 millimeter, it's about an 8x8 hot plate down here that it's working on. You can mount metal onto it or glass, and then you could use a laser to etch it, but it has to be a pretty powerful laser. And it could mount, you could remove this head and mount a router on there or whatever.
Dave, come in.
Yes, Mary Frances?
Why don't you tell Ken Bixler, since you are showing examples, we can't get people to come around the corner here and look at our beautiful sign, electronic sign that Ken Bixler and Rich Allen made using the CC unit. We're correct, Ken?
CNC, it's called computer numerical control.
Anyhow, a lot of people look at this and just think, oh, it's a piece of black plastic. I wish you guys would look at it more careful and realize that people like Dave Clement, Rich Allen, Kenny Bixler, and so forth, they're actually making these things with machines similar to what Dave Clement's talking to you about.
I had a lady tonight talk to me about, she works with toys and rebuild different things that might be minus a part. And she said, would this be a good thing to do it with? And I said, so long as it's fairly simple, you know, you can't, at least I can't. I don't know how to use CAD software that great. But there's also, if you want to spend the money, you can buy the gadget that I said that you have a carousel unit. It's all automatic. You just take your objects, you sit out on it, and it will photograph it. Make a 3D image and put a file out like the STL that's needed. And then you can modify it, take the thumb off and rotate the thumb around, flip it around, and you got it.
Sounds like LiDAR. What it sounds like.
I'm just not familiar with, I have a terrible time reading. I have dyslexia. I was in charge of the computer department and a photographic department at Owens Corning Tech Center for 37 years. I could read the manuals somewhat, but there was a lot of spaces in between that I was able to figure out. And so I'm not familiar with the name. And I would imagine they call it, there's probably units out there that they name 20 different names on. And that. But it is a very interesting machine. If you want to come up and take a look at it, it's doing an infill right now. When the infill is where it's doing pattern that is going to give it strength but make it very light in weight and cut down the amount of the fiber that you're using. And you can change that infill in it from 0 amount, not putting anything in there, to 10%, 100%, back to 50%. The Cura software gives you the capability of changing that in it. And when it changes something, it will recalculate it and it will tell you exactly about how long it will take to make it. I've had some pieces that have been 14 hours. And I turn it on and let it go. And the only thing that I've done that are special are the orange or the reddish fiber things. Those are the things I made and added to it. And I put it on a piece of wood because I couldn't get the heated table to be level, and that's where it builds the object at. And so I made some fasteners to hold it down to the board, loosened up the bolts, let it sit itself down at its seat, perfect level, and now great. And I have what they call a bed leveler, which is a $18 piece, and it takes and checks it in 9 different spots across that hot plate. And if it's off a thousandth of a degree over here, it adjusts the drawing so it will be level. And it's pretty neat. And I mean, for $119,
A lot of fun.
it's a lot of fun. They say it's made out of plastic, and they say it'll break. Now, I've had mine for a year. My grandsons have used it. I have used it, And if I'm breaking fans with a screwdriver, I probably hit it a couple other times. But, is there any other questions?
Was it hot when it gets done, or is it cooled on the way up?
It will
How's
cool
that
off
work?
in about, if you try to remove it off the hot plate is running at 65 C. At 60 C, I've had it work loose. It comes loose from the glass. Most people have a special, they either use masking tape and they put down and they build on masking tape, or they have a $12 piece of material that's laid down.
The baking sheet thing?
Yeah, like a baking sheet thing, similar to that, but it has adhesive on one side, and it's very hard to get off the aluminum plate, heated plate, if it gets ruined. And I've ruined mine because I've had the head, which comes to a point, and it had actually poked a hole in it because the bed leveler wasn't working right. And you got to stop it. That's why I have a little switch right over here. I can take it and stop it. I don't want to stop it now. It's just a lot of fun. And it's not a lot of, well, I don't know. If you ask my wife,
Yeah,
it's probably a lot of expense. But I've also fixed her stove with it. The lower drawer under the bottom of the stove, the nylon thing broke that it glided on the right side, the drawer falls down.
Yeah.
Dave, can you fix this for me? I picked up the piece that's broken, and I said, oh yeah. Went downstairs, okay, drew it up on the Tinkercad, and made it. And if I could get into Tinkercad, you could see all the stuff I've made, and that. And I'm into model airplanes too, and I'm making motor mounts and the whole 9 yards. And
On the skeleton head and skull, did you go off of something on the internet to get that?
I went on the internet. That was downloaded. You can like I said, from that Fame Universe, you can go on there and they literally have, well, you can go, just put down 3D STL files, and
Go through it.
you can get a list a mile long. Some people will sell them. There's 2 or 3 places that does it for free. They put them on there. Anyone's allowed to take them off and use them. You can then change the size of it, the whole 9 yards. You can add the thumb if you want, you know. And that's what I did to these. These were purchased, but I added these little tips here were for rubber bands. The X in the bottom, piece across here to hold the camera, keep it from dropping down into it. And the thing in front that held the camera lens was too high and was in the way of something, so I modified that. And so you can take an existing drawing and modify it. So it's a neat community. Yes.
What's the name of that software you said you picked up free on that?
Cura. Yeah, it's on that sheet I gave you. It's called Cura. C-U-R-A. And it is totally free. And a lot of the software is free. You know, like the Tinkercad. And if you have a young child that is interested in making things, turn them loose with that. And you might have the next $1 million thing. Yes.
Earlier, we saw a picture of a range.
Of a what?
Earlier, we saw a picture of a range on the screen up there, and it had the range divided into 3 parts. Does that imply that a wrench could be made with 3D printing?
Yeah, a wrench could be made with 3D printing.
Well, how would the 3 parts be connected together if they're made
Okay.
3 separate pieces?
If I kept it up there, the 3D CAD builds the STL file that you use in Cura. It does the slicing, so you need 3 or 4 items to do something like that. With the Cura, or with the Tinkercad, let me go back to it. And maybe I can get to, let me go back here. Okay. Here's where he's going to start adding these parts together. He's going to make the head of it. He's going to take this piece right here, which is he's going to use to make the dimension of the nut that it's going to have to fit over. And he's going to put it in this piece right here and make a hole in it.
Gonna subtract the two.
Yeah, he's going to subtract the two. And you can see now he can change those measurements on it. So if it's a 1/4 inch thread or a bolt, he can make a 1/4 inch, both of that, all of that rectangle, and make the part. Then he adds it to it. And then he can align it. He's aligning it with these arrows right. Well, I can't get on it. You can't see my mouse move around. Yeah, but he's aligning it using this. This will go center, out in front. Okay, he subtracted that piece there, so now he's got a hole through the plastic. Now he's going to join, I think, the head here to the body, or the shank.
But when it builds it, it'll all be one piece.
When he's through with it, it'll be all one piece.
It's not three.
Tinkercad is, now in real CAD software, you would design it. Boom, 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 boom. But in Tinkercad, they use it as a toy. They said, oh, the kids could take this building block here and put it in, and they came up with a cow. Okay, so, but that's why they're trying to teach kids and me, I'm 75 years old, how to do it.
Once you're same strength or as good as a forged steel ring?
No, no, it's made out of plastic, but they have carbon fiber out now. I don't know what the cost is, but you can make it out of carbon fiber, and they said it's 10 times stronger than steel. I don't know. I heard some remark about how many times stronger it was than steel. And it gets done with this. I don't know the temperatures that you have to melt it out. PLA is what I use. It's an inexpensive, very flexible kind of soft material. But you can see when I fill a part like one of these, or even one of these, it's tough. And, you know, I could press this. But it took a lot of strength to make a 1/16 of an inch. And that PLA melts at about 100 or 210 C. 210 C, which is around 500 degrees. And then they have a ABS, which is about 4 times stronger. It melts 240. Okay. Centigrade. Is there any other questions?
Yeah. How many passes did it take to make these rolls? I'm trying to get an idea.
It took about 10 minutes to make them. I couldn't tell you. I get like 15, I do 15 at a time. And what that saves you,
Sunday, we're gonna go Saturday.
when you do it on glass, you have to let the glass cool to get them all.
Can I sign up online and
And
figure out?
oh,
that's for bringing food. Oh, I see. Oh, okay, so if we do come, I will bring some. Yeah.
Because it's gonna worry about height. It's not gonna change the height as it goes
Yeah,
from
that'll be
unit to
Sunday.
unit to unit.
So
It's the same height. Makes this one brighter, makes this one brighter, so on, so on. And it goes to finish. So you set the time of what is heat up.
Oh, this thing is Sunday?
And start it, where the chance of getting all the line.
Each layer is about the same.
Thickness depends on what you
One
put
size
on.
each layer.
Oh, it's approximately, because it squashes the top of the pad. Just smooth it off, make a soft line, smooth line towards the next one. If you rub your finger on the side, like this, you could feel, yeah, and you can feel little ridges, and you can tell how I had it set, this one is smooth on this side, so it was sitting on the hot plate this way. So we're rubbing it that way, you can hear it. And what a lot of people do, they'll take all of the spray case, the gray ones, because it has a filler on it, and they'll spray a coat of paint on it, and then they'll sand it down with water-based sandpaper, and it's a primer. And then give it a coat of regular paint. But I would say that you could probably undo a bolt with that wrench if it wasn't tightened down real tight. Okay, is there anything else? See, now he's got it all put together. Then he would go up here, and there's up here in the upper right-hand corner, there's export, import. So he wants to export that out, and he could export it out to his PC at home. That's what I do. Now, I use Firefox. Firefox doesn't work with it. I have to use Chrome. That's the only drawback, is I have to use Chrome.
What's wrong with Chrome? I use both of them.
Oh, that's fine. I'm just used to using Firefox. And I tried it with Firefox, and it wouldn't work.
A lot of auction sites won't work with Firefox.
And so I read up on it, and I said, okay, fine. I say Chrome is the one they say try to get rid of the problem. But you can go on this website, YouTube, and anything you need to know. It's a great learning area. I wouldn't trust what a lot of them say, but you know, is there any other questions? Okay, well, we're free to.